Well, class, we are on wonderful pattern recognition. So let's get started with our pattern recognition here. Here's just another example. We have on another street, the house numbers follow the rule subtract 5. So what are the three next house numbers? Describe a feature of the pattern. So I start at 25 and I subtract 5, so my number becomes 20. Subtract 5 becomes 15. So what's a feature of it? Well, a feature is they're all multiples of 5. You could also say they all end in 0 and 5. And the reason they end in 0 and 5 is because it's a multiple of 5. So those are just some examples that we have. So now let's head on to number 1. It says Rudy's rule is add 2. He started with 4, so let's start with 4, and wrote the numbers below. Which numbers does not belong? Well, remember, we're adding 2 each time. Plus 2. Oh, that's the one that doesn't belong. 8 plus 2 does not equal 9. So what do we write? Well, which number does not belong? 9 does not belong. Next, I'm writing in a weird spot, so let me put it down. 9 does not belong. And then we'd have that explanation. Well, 8 plus 2 equals 10, not 9. So that's our explanation. Heading off to question 2 now. Continue the pattern. Describe a feature of the pattern. Well, subtract 6. So minus 6, minus 6, minus 6, minus 6. So now I need another minus 6. 24 minus 6 is 18. 18 minus 6 is 12. 12 minus 6 is 6. So now what's the feature? The feature is and we're going to put they're all multiples of 6. Another feature we could put is they are all even. I'm sure there's other features, but those are only 2 I found. Now, since it just said A, you only need one of those. Number 3, continue the pattern and describe a feature. Subtract 3. So then we have 15 minus 3 is 12. 12 minus 3 is 9. And what's our feature? They are multiples of 3. Every one of these is times 3 is a multiple. So that's 3 times 3. That one is 4 times 3, 5 times 3, 6 times 3, 7 times 3. So they're all multiples. Number 4, we're adding 7. So we add 7. We add 7. 18 plus 7 is 25. 25 plus 7 is 32. What's a feature? Well, here they're not all multiples of 2. They're not all multiples of 7. So the only feature I can see is that it goes even, odd. Even, odd. So that's the only feature I see. There's probably more, but that's the only one that I can spot. Number 5, add 5. So 5, 10, 15, 20, 25. We're adding 5 to each. And what's the feature I see? Well, the feature is they are multiples of 5. Off to number 6, add 2. Well, we have 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, and 11 plus 2 is 13. What's the feature I see? Well, they're not all multiples of 2. The only feature I see is that they're all odd. Now let's go to our next one, number 7. And number 7 is different because it doesn't always describe the feature. It just says use the rule to generate the pattern. So what number comes next? We're going to subtract 10. 90 minus 10 is 80. Subtract 10. 80 minus 10 is 70. Number 8, we're going to add 11. 16 plus 11 is 27. 27 plus 11 is 38. Here we're adding 5. 96 plus 5 is 101. 101 plus 5 is 106. Over here, our rule is add 4. 43 plus 4 is 47. Add 4. 47 plus 4 is 51. Subtract 15. 120 minus 15 is 105. And then 105 subtract 15 is 90. Our last one for this page, our rule is subtract 9. Well, 99 minus 9 is 90. 90 minus 9 is 81. So pretty easy if you can do those in your head. If you can't, then you have the problem of not knowing your math facts as well, and it will just take you a little bit longer to get them done. Now let's head to number 13. Orlando delivers mail. He sees one mailbox that does not have a number. If the numbers are in a pattern, what is the missing number? Well, what pattern do I see here? Well, it looks like we're adding 2 each time. So let's start at our number right before the missing number and head on over. So 29 plus 2, our number is 31. Doesn't ask for an explanation, so we can head on to the next one. A bus tour runs 9 times a day, 6 days a week. The bus can carry 30 passengers. Find the greatest number of passengers who can ride the tour bus each week. So let's see. So 9 times a day, it can carry 30 people. So in one day, that is 30 times 9. In one day, it can carry 270 people in one day. And now, how many days are there? Well, there's 6. So that would be 270, 270, 270, which I could add these numbers up, but I'm such a good math student in 4th grade, I'm going to just multiply because I see that's repeated addition. So that's 270 times 6 days a week. So that's going to be 0. 6 times 7 is 42. Regroup the 4. 6 times 2 is 12. Plus 4 is 16. So in 1 week, it can carry 1,620 passengers. Heading off to our next one. The year 2005 was the year of the rooster on the Chinese calendar. The next year of the rooster will be 2012. The rule is add 2017. What are the next 5 years of the rooster? Well, let's start. We have 2005, then 2017, and now what do we need to do? We need to add 12. So 17 plus 12 is 2029. Then we add 12. 29 plus 12 is 2041. Then we add 12. 41 plus 12 is 2053. We have 1, 2, 3, and it needs the next 5. So let's keep on going. I'll have to slide this over. Plus 12 is 2065, so that's 4. And our last one, when we add 12, is 2077. So there we go. The next 5 year of the roosters. And if you want to see what the zodiac calendar looks like, it just looks like this right here. Now our next question says, suppose you're born the year of the snake. How old will you be the next time the year of the snake is celebrated? Now, there's 2 ways you could do it. You could say, well, since it's a pattern every 12 years, you could say I will be 12 years older. Or you could actually figure out the math. So you're all different ages. So we'll do Mr. Embley. So I am 33 years old. And then the next year of the snake would be plus 12. So then what would that be? So you could also say it's going to be 45. Now, this isn't quite as good because it's actually not really what the question is asking. It's really asking for this. But if you actually figured out how much older you'd be the next time it would come around, you could do that. Or you could have said, well, I was 0 when he was born. This is what it's really asking. And then the next time would be 12 years later, so you'd be 12 years old. Any of those would be acceptable, but these 2 are the most correct. Okay, our next one. Define rule, and then create a number pattern using the rule subtract 7. So we have 2 different things going on. What is a rule? Well, a rule, let let me zoom on in for us, is a math phrase, or if you want to be super fancy, you could say mathematical phrase, that tells how numbers in a pattern are related. And then we have our rule of subtract 7. So let's start with just some random number. I'm going to start with 70. And then using that rule of subtract 7, it would be 63. Subtracting another 7 is 54. Subtracting another 7, oops, not 54. Mr. Wimbley did horrible math there. 56. Subtracting another 7 is 49. 42, ... Now, why did I pick this one? Well, it's easy because a feature of this pattern is they're all multiples of 7. So as long as I knew my 7's facts, I'd be okay with it. Number 18 now. Some patterns use both addition and subtraction in their rules. The rule is add 3, subtract 2. Find the next 3 numbers in the pattern. Well, what do we have here? We add 3, and then we subtract 2. We add 3, subtract 2. Add 3, subtract 2. Add 3. So we see the next one should be a subtract 2. So that will be a 5. Then we add 3. Then we subtract 2. So notice, actually writing this out, especially when there's more than one rule in our pattern, is really helpful because I can see which one comes next. So sometimes you might be able to do it in your head, but a lot of the times, especially when you get older, your patterns are going to be more complicated. So that's why we try to write these patterns out. And we start with those easier ones, so when we get to the harder ones, you see how to write them down. Now, we have our last 2. Rima used subtract 3 as the rule to make a pattern. She started with 60 and wrote the next 6 numbers in her pattern. Which one does not belong? And then she's also saying, if we're stuck, which one's not a multiple of 3? Well, we have 60. Subtract 3 would be 57, which I see here. Subtract 3 would be 54, which I see here. Subtract 3, get 51. Then we subtract 3, get 48. Subtract 3, get 45. So our answer is D. Now, let's check, because I think she's giving us a hint here as well. Which one's not a multiple of 3? Well, if you remember, we can find multiples of 3s by adding those digits and seeing if they equal a multiple of 3. So this would be 12. 12 is a multiple. This would be 9. 9 is a multiple. This would be 9. That's a multiple. This would be 8. And when I added 2 plus 6 to get 8, 8's not a multiple of 3, which confirms that this is my answer. That one's not part of our pattern. Number 20. I've counted all the beans in a jar. If you count the beans in groups of 7, so remember, groups of 7 is division or multiplication, which list shows the number Ivan could have named? Well, since we're getting bigger by groups of 7, it's multiplication. So let's see if one of these matches. And then he's also counting by 7s, so we actually don't even need our multiplication. So here is plus 7, plus 7, plus 3. So it's not this one. Here we have plus 7, and then a giant jump. That's a times something. I don't even know what they did there. So it's not this one. Then we have plus 7, plus 7, plus 7. So it looks like it's going to be this, but let's check our last one. Here is plus 10, plus 10, plus 10. So yeah, our answer is C. Good job, you guys.